Greetings and welcome to my new calculus channel. My name is John Gabriel. So I'd like to, in this video, just give you a little glimpse out of this fantastic book that I'm busy writing and that has a lot of information in it already, and it's available for purchase. It's called The Importance of Learning the Right Way and What Does Division Mean in Mathematics, and How Does it Affect All Other Arithmetic Concepts. So this also features my unique theory of learning, which is called CATIS. Let me give you a glimpse of it. So the concept of division is inseparably linked to that of number. It's impossible to fully understand, possible to fully understand the concept of number without division, So number, let's just make this bigger to make it easier on my eyes. Number itself emerges from a process of division. That's right. I bet you didn't even think of that. As discussed throughout this text, number arises from a measure. By the way, you probably didn't think of this before because you think of division as a subtraction process. But it doesn't have to be a subtraction process. It could also be an addition process. So number arises from a measure, and this identification process is closely intertwined with measurement. In fact, you can't separate the two. So if you consider two line segments, P and Q, and by the way, P and Q are not numbers, they're line segments, like this. P is the red line and Q is the blue line, where P is 3/4 the length of Q. Right, we haven't actually measured them right now. I'm just adding that in as a bit of side information. The measure of the ratio PQ of these line segments is determined by counting how many times a common divisor D, represented by either the green or the orange line, fits into each line segment, or measures each line segment. So as you can see, here when you're performing a counting process, you're actually dividing and you're measuring, because you're counting how many times D fits into each of the line segments, right? So this measure is then expressed as the quotient of the counts. So if you say the count of P, the red line segment, over the count of Q, the blue line segment. So this here is the number itself. So the number turns, while the ratio is P to Q, the number is 3/4, That's how we arrive at number. So while the same ratio can have equivalent representations, such as 6/8 or 12/16 or whatever else, innumerably many, the measurement processes differ. In the case of 3/4, the unit is one of 4 equal parts. This is what the bottom number tells us. It tells us the number of equal divisions of the unit. And in the case of 6/8, the unit is one of 8 equal parts. And by the way, this is why you can't have 0 as a denominator, because 0 is not a number and the unit cannot be divided into 0 equal parts. So those infinitely stupid PhD students writing dissertations on division by 0 and what have you, they're just totally off track. They don't know what they're doing. And this is another reason why you cannot have 0 as being part of the numbers. It's not a number. So each representation uses different divisors or units, yet they both describe measures of the same underlying ratio. This same underlying ratio, red line to blue line. This distinction is critical in understanding the true nature of numbers as measures of ratios. I have always said, and I was the first to say this, that a number is a name given to a measure that describes a ratio of magnitudes. Magnitudes are not numbers, So 3/4 and 6/8 are not ratios. They are numbers, Two different things, not ratios, numbers. The ratios 3 miles to 4 miles and 6 inches to 8 inches share the same measure. They have the same measure, but they are not the same ratios because 3 miles is not equal to 6 inches and 4 miles is not equal to 8 inches. Do you understand that? So 3/4 and 6/8 are numbers that describe the measures of ratios. Now, although these ratios have the same measure, they represent different magnitudes. Okay. As I've said again, and I repeat this for emphasis because people don't pay attention, 3 miles, which is the antecedent that is being measured by convention, by the way, it's not equivalent to 6 inches. Okay. For two ratios to be equal, both their antecedents must be equal and also their consequence. Let's go over that. So if you want this red and blue ratio to equal to, let's say, another ratio, then the red line, which is the antecedent, must equal to the antecedent of the other ratio. Okay. And the consequent must also equal to the consequent. It's not enough that they're in proportion for them to be equal. They have to be equal, they have to be in proportion. Okay. But to be in proportion, they don't have to be equal. Stop the video and think about that. So what's important? Important is that this ratio, 3 miles to 4 miles, is not the same as 3/4, which is a number, okay, that describes a measure in terms of the abstract unit and is independent of physical units, okay? 3/4 is independent of physical units. It provides a measure of the ratio without regard to specific quantities or dimensions involved. Unlike the ratio, which basically just shows the proportionality in terms of physical line lengths or masses or volumes, etc. So mainstream mathematics academics have, as a result of their sheer ignorance and arrogance, and may I add, incorrigible stupidity, conflated these two concepts, causing endless confusion for those wishing to learn mathematics. So let's summarize. The ratio 3 miles to 4 miles is mathematically distinct from the number 3/4. The latter is a number representing a proportional relationship independent of any physical units. Okay, in other words, 3/4 is a measure in terms of the abstract unit. When we write 3:4, we're expressing a numbered ratio. Okay, it doesn't have to be numbered, it can be written as line segments like we did here. Here it's not numbered, it's red line to blue line. Okay, but here, where are we? Yeah, the ratio 3:4 is a numbered ratio that can be applied to any magnitude. Okay, not just numbers. It captures the fundamental proportional relationship. In contrast, 3 miles to 4 miles explicitly involves physical quantities that are measured in terms of specific units. The abstract unit does not care about type or size. Both those two characteristics or attributes are not needed. They're irrelevant to the abstract unit. So again, these concepts are always presented without clear distinction, and that causes a lot of confusion and problems, especially in theoretical mathematics and practical applications, such as physics and engineering and architecture and anything else STEM related. So this wonderful book, which I've written, describes this and much, much more. Okay, I could give you a very quick glimpse of this thing here as you go up. It also incorporates my theory of learning, which is CATIS. Okay, so you'll learn more than you've learned in all your university and school years. It's a fact. And you can buy it on Amazon at this link here. And it's updated every time I have the chance to update it. And if you're a members only, you get access to this members only folder where I share a lot of goodies with those who pay me €5 a month. It's just the price of a cup of coffee or your favorite drink, and you're supporting the world's greatest mathematician. Just think about that. For 1 cup of coffee a month, you can secure your children's mathematical future. In fact, you can secure their STEM future. Because look, If your children do not understand mathematics, they're not going to follow a career in STEM. Okay, so, and they're not going to like mathematics. You can't like something without understanding it. And don't believe anything those morons in mainstream academia tell you, that people cannot master or are not born to master certain topics. Mathematics can be mastered by anyone if it is taught correctly. All right. So if you're not already a subscriber to my YouTube channel, become a subscriber, click like, tell your friends about it, your family, everybody else you know, spread the news. And follow me on academia.edu. There'll be links to all of these. And yes, become a member of my members only channel. I'm John Gabriel. Till next time, goodbye.